Yeah. So, we did that yesterday.
Well, there's probably
We're out of videos to watch for this section. So look, just so y'all know, here's how this is gonna go, because we got 6 weeks test next week. We're gonna do the exploration today. We're finishing up this section of Discovery Education. So Monday, we're gonna take, All right. Monday, we're gonna take a unit. It's the unit assessment. It'll be a quiz grade, but it's one of the multiple choice ones that kind of covers all the different questions. And then Tuesday and Wednesday, we will review. I'm gonna try to go over the review extra detailed this time, because my test grades and all my classes were not as good as I would have liked. I was actually kind of down about it, and then today Mrs. Sell was telling me how many of her students are failing. And it made me feel better, because it's not just me.
hers are worse.
It's a little, yeah. Cecil's always a little bit tougher, but where I don't know what it is. I don't know if it's the mask, if it's just the Rona and everything that's going on. But yeah, everybody doesn't. Teachers and students included don't seem to be doing as well as last year. So I'm gonna try to up it up and bring the review game, and then maybe we'll have a little bit better test this 6 weeks for the 6 weeks test instead of 3 weeks test. So we're starting at the front for all of y'all that don't know how to get to these by now, and for the people at home, because I got a couple people that are absent. Click on these, and if you sit in class and you're like, I just don't feel like it today, and you don't get it done, there's no due date on these, and so if you get it done before I put it in the grade book, I won't know whether you did it in class or not. So you can always go back and watch the video and make sure that you get it done. I might put grades in this weekend, so this one you don't have a lot of time on. Try to do it today while I'm doing it. But go to the exploration tab. You're already on the exploration tab. Go to explore more resources, because they're really hammering home the exploration thing. Explore tab, explore more resources tab, and then go all the way to the very bottom and click on the green one. Make sure it's the very bottom one, because there's another one where you can't fill out the questions for it. Good news on this one, we might omit a couple questions, and you don't have to do that second page. We always have a problem with people not doing the second page or the first page or whatever. This second page one is like a big chart. You don't have to fill all this out. Let's just concentrate on the 1 through 10 questions. So make sure you're on the 1 through 10 questions. I'm going to show you this part a little bit, just because I think there's a couple questions that they ask about it. So I want to see if we can maybe suss out a couple answers for that. So they give you an introduction. They talk about what's going to happen. We're basically going to look at some fossils and try to figure out some dates for some fossils using a scanning electron microscope. They tell you to get familiar with the equipment. So they have the experimental setup here with your scanning electron microscope. And the way this works, they basically shoot electrons at whatever your sample is. And then they have sensors that read where the electrons bounce off of your sample. And a computer takes all that information, kind of plays it backwards, and they get an image out of here that's the detail of basically like the width of an electron. It's probably a little bit bigger than that because of error, but you can get much smaller detail than you would be able to get with your eyes, even with a really highly magnified regular telescope. So you don't put your eyes up to this one and actually look through it. It shoots electrons out. It gets processed through a computer, and it's got to show up on like a computer screen for you to be able to see what's going on. And then we click over to the scanning electron microscope. It shows you kind of how that works. So you have your electron gun. You have a couple condensing lenses that change the direction that your electrons are traveling. You shoot them down through here. It actually hits your sample, which is on this plate, and it gets recorded. So you have an objective lens. You have a secondary electron detector, and they figure out where the electrons bounced around at and put that into the computer, and it gives you an image out. They do have, let's see, sample preparation. I was wanting to know about this because in here, they have you like coat your sample. Make sure that they are coated with extremely thin layer of conductive materials such as carbon or gold. This is done using an instrument like the sputter coater. So basically, to get your electrons to pass through and actually hit your sample in the right way, it needs to have a conductive material on it. So I guess they coat it with carbon or gold, which is actually pretty cool. You put like a thin layer of gold all over it. I imagine it's probably a lot cheaper to do the carbon instead of the gold. But that's what you got to do in this sample. So go to the Explore tab. What part of the world do you want to look at fossils from? Just pick one. North America? That's a little cliche, but we'll go with it. So North America, we got 2 fossils here, fossil 1, fossil 2. Click proceed. Take your sample, put it in the sputter coater and coat it, and it's going to coat it with a layer of gold because in fake life on the internet, we can be as rich as we want to. We'll just coat our dinosaur bones in gold. So coat it with gold. When you're done, you can click proceed. Go to proceed, take your sample, put it in the scanning electron microscope chamber, and it tells you this is a fossilized dinosaur bone. So it tells you a little bit about it. These holes are holes where the blood vessels flow through the bone. So you can see really, really tiny detail that you wouldn't be able to see with a normal microscope. They analyze it, and they find out, I think this is supposed to be like a T-Rex bone. So is this a trace fossil or a permineralized fossil? What's a trace fossil?
It's like an imprint.
Yeah, it's like an imprint. It's like a mold. It's like an imprint. It's a tunnel that was dug. This is an actual bone, so this is going to be permineralized. The bone material has been replaced with minerals, and you get basically a representation of what the bone used to look like. So this is a T-Rex fossil. They tell you a little bit about it. You click proceed. They tell you it was in the Cretaceous era. You look at the geologic time scale here, and if you go up and look at Cretaceous, they have a time frame on the side which tells you it was like 140 something million years old, all the way up to like 65 million years old. So click on that one, and congratulations, the T-Rex fossil is between 146 and 65 million years old. So basically, you just do that over and over and over again, which may be, I don't know if it's super necessary, but that's what they have you do. So you scan this one. It's dinosaur soft tissue. It's not a trace fossil. It's a mummified piece of dinosaur tissue. So you proceed. They tell you about the age. It's in the upper Cretaceous, which would be up here. So it's like, I can't even read the words, but it's about 77 million years old. Wonderful. So let's start to look at some of the questions. Question number 1, list the conditions necessary for fossilization. So that's going to be back here in the book. I'm like sweating in this hockey gear. Come on. Which normally isn't a problem because you're on the ice and the ice is cold. So it's wonderful.
Good line. Ice is cold?
Yes, it's,
No, really?
it happens. It happens.
Well,
Do y'all like playing football in the cold better than
No.
I like running.
No. Is it because it stings more when you get hit? Yeah. No, I remember that. So what are the conditions for getting fossilized? They have that. You want rapid burial. You want a gentle burial. It can be burrowing. That would be nice. Let's see. Do they have better conditions down here? How do fossils form? Preservation. Do they mention the hard parts? Yeah, hard parts, definitely. So you got to get buried in a fast and gentle way. Ideally, you want to be buried in the right scenario, and you want to have hard parts. That's what you need to become a fossil. Where are we at? Here we go.
He said pay attention.
Yeah, pay attention. And it's in the book. But what do you need to become, what are the conditions necessary for fossilization? Rapid burial. You got to be buried quickly. You got to be buried without being destroyed. So a gentle burial, quick and gentle. You got to be buried in the right condition, preferably without oxygen there, so your body doesn't decompose. And you got to have some sort of hard parts. The more hard parts you have, the better you are off for being fossilized. So number 2, describe 3 ways that the fossil record helps scientists understand Earth's history. This, I don't know that they say this outright in the book, but I can think of 3 ways, or at least 3 ways that I would describe it. Because, yeah, they go through the different types, but I don't know. It's a little bit in here. So that's going to be one of them. Let's just go back to the question and talk about it. So, that's not it. So describe 3 ways that the fossil record helps scientists understand Earth's history. They help us understand what animals were alive in a certain period, which tells us about the conditions. So if I find fossils from a land animal in a certain area, I know during that time it was above water. It wasn't underwater. So it tells me what was alive. It tells me where they lived and what the conditions were like. And 3, it tells me about their evolution, because I find lots of different fossils. I can see how they changed or didn't change or died off as time went on. So those are going to be the 3 ways. Those are very simplified, but those are going to be the 3 ways that I can think. They tell me what was alive, what the conditions were like when they were alive, and how they changed, both the conditions and the animals themselves. The evolution of the animal and the evolution of the environment.
Number 2.
Yeah, that was number 2. Compare and contrast a mold and a cast. So this one's pretty easy. Does anybody got a guess? You got 2 parts. You got a mold and you have a cast. Which one's going to be which? Which one's going to be the inside? Which one's going to be the outside?
Mold is inside.
The mold is going to be, in this case, and see, this is kind of different because we use the term cast in a different way when we're talking about like a medical cast, because the cast goes on the outside. A mold is going to be the outside. The mold, think of a mold like an ice cube tray. And the cast is going to be the ice cube itself. Yes, the mold is going to be like the outside, and the cast is going to be something that fills in the hollow area. Yes. So that's going to be the difference between the 2. The mold would be like an imprint of the shell. The cast would be like the snail or whatever inside the shell dies, and the mud fills in the inside, and I get to see what the inside of the shell looked like. What? Yeah. So the mold is like the outside, like an impression of the outside. The cast is going to be like an impression of the inside, like the inside gets filled up, the empty space, like Junior said. So number 4, what is the difference between a body fossil and a trace fossil? What's the difference? You already said what a trace fossil is. Say it again. What's a trace fossil?
Like the imprint or something.
Yeah, it's going to be like an imprint, like a footprint, like a tunnel that a burrowing animal dug. Those are going to be your trace fossils. A body fossil is actually like a part of the animal, whether it's a bone, whether it's like a mummified thing where it got trapped in amber. Body fossils are an actual part of the animal. A trace fossil is something that the animal left behind that's not part of its body, so like a footprint. And then it says compare and contrast the information that a body fossil can give us with the information that a trace fossil can provide. So body fossils tell us about like the structure and the composition of the animal. So like what kind of bones did it have? How tall was it? Where were the muscles at? Because we can see on our bones where the muscles attach. Maybe how much did it weigh? This and that, all that kind of stuff. Where'd it go? The trace fossils are going to tell us a little bit more about what they did. So like when we talked about the footprints in Glen Rose down in the creek, if you see multiple footprints, you can see how far apart that dinosaur would step. You could see how fast it could run based on the steps. You can kind of extrapolate different information. So the body fossil tells us about the animal itself. The trace fossils tell us about what the animal did or what it could do. Like if you find a body fossil inside of a little burrow, that tells you that that animal dug its own holes or used other holes that were already dug. So yeah, body fossil tells you about the animal itself. Trace fossils tell you about what the animal could do or did do. Which has a better chance of becoming a fossil, a clam or a spider? back up your answer with evidence and reasoning. So what do you think? Clam or spider? Clam. Why? What does clam have that a spider doesn't really have? Hard shell. And now, to be fair, spiders, well, some spiders kind of have that hard, like, exoskeleton, but it's not that hard. When you step on it with your shoe, they go squish instead of like crunch. Yeah, they're going to be a lot less likely to survive. Now, if Gage was here, he'd probably be like, but a spider could get trapped in amber, and that would be better preservation. Yes, but that's going to be less likely. So you're wrong about that, Gage. But yeah, the clams, you can find all sorts of clam fossils because that hard shell is something that's easily going to be preserved. Explain how scientists might be able to determine the relative age of a layer of sediment if they find a fossil of a particular species of trilobite in the layer. So, relative age. They don't need to know the exact age. They just need to know whether it's older or younger than something else. How they find that is they actually study the trilobite itself. It's not just a random trilobite. It's a particular species of trilobite. Those animals changed a lot. So if you can go in a book and figure out what that exact species was, you can generally know where it went in the lineage of trilobites, whether they got bigger or smaller, or their heads got wider, or they got more sections in their carapace. There's all sorts of different things that trilobites change. So by knowing that particular species, you can get it narrowed down to a small range of time before or after other different animals. And to be fair, because we've already done the work, you can probably get it to a specific time too, if you're using the book. All right. Is that just another one that I had open? Yeah, I'll need two of them. All right, so the next one, it says describe 4 different ways that fossils can form. They've got them right here in the book. There's actually more than 4, I think. But so preservation of original material. That's going to be like it gets frozen in ice, it gets stuck in a tar pit, or it gets stuck in amber, and it doesn't decompose. It just stays like stuck in that like time capsule forever. That's going to be your preservation of original material. Sometimes it's hard to find and hard to look at, but they get mummified. So next is carbonization. So you have preservation of original material, then carbonization. Basically, your body decays and degrades down, but the carbon inside gets kind of locked into the rock. And so you kind of get an outline of the different parts of the body, your bones, maybe your hair, maybe not hair, but wings, feathers, scales, tails, stuff that really wouldn't be preserved if we're just looking at bones. So carbonization. And then you have 2 sides of the same coin, permineralization and petrification. Permineralization occurs when your pore spaces in an organism are filled with minerals that precipitate out of solution. So basically, parts of you get replaced with minerals. That's permineralization. Parts of you get replaced with minerals. Petrification, all of you gets replaced with minerals. You basically turn into a rock, like petrified wood. But we come behind and we can see all the details in what would have been your bones or pieces of wood. So those are the 4. Preservation of original material, carbonization, permineralization, and petrification. And they even have another one, casts and molds, if you want to throw that on the end. Just for good measure. Where are we at? All right, 8. We're not too far. Why would a scientist use scanning electron microscope instead of just a light microscope to examine a fossil? You're going to use a scanning electron microscope when you want to see the really, really fine details. If you want to see something smaller than you would be able to see with just your normal eyes, that's going to be when you go to a scanning electron microscope. So very, very small details, less than just a regular magnifying microscope can get magnascope. I don't even know number 9. Give me a second. We'll see if we can figure it out. It says, describe a situation or investigation of fossils in which a scanning electron microscope would not be a useful tool. Explain why it would not be useful. I don't know if there's like no small details at all, but that doesn't make sense. There's always some sort of small details. Maybe there's certain materials that won't work well in a scanning electron microscope. Let me see if I can figure that out, but we might just skip that one. In the exploration, use the geologic time scale to infer the age of a particular fossil. How do you think scientists made the geologic time scale in the first place? What information did they have to gather in order to make the time scale? We had to gather fossils. We had to look at rocks. We looked at rock layers. We looked at fossils. We got information about the time frames for those rock layers and fossils. And we kind of started to compare all of those things, put them in a list, and put dates on the list. That's a pretty general question. How did scientists create the calendar? Yeah, we looked at fossils. We looked at rock layers. We got ages for both of those, relative and absolute ages. And then we started to compare them and put it all together into a big list. Let's see real quick if we can figure out the electron microscope thing. Apparatus. Advantages, maybe it'll have disadvantages. Several advantages, yeah. Much smaller objects, yeah. The depth of the field is also greater. The amount you can focus. Images with the high depth of field look 3D. Principle and working, nah. I don't know. When would you not want to? So we can omit number 9, but just if someone Google it real quick, just so I feel better and know. You don't have to put the answer in, but when would you not use a scanning electron microscope? Come on, John, Google it for me. Let me know. Just for informational and educational purposes.
Certain colors cannot be determined by a stem or a stem.
Okay, so yeah, if you're trying to look at colors, that's perfect. If you're trying to look at colors, y'all don't have to write it in. We can omit it because it's not in the actual discovery education itself. But yeah, that would make sense because if you look at the images, like if we come back over here, they're all going to be black and white like this. You're not going to get any colors. Perfect. Awesome. So before I close this out, anybody got questions on any one of them? Let me go over them again. Fill in the blanks. Let me know. I'll leave this up. If you have any questions, let me know. For those of y'all at home, probably just Brandon. I doubt any of the absent people will get on and look at the video. I don't even know if Brandon looks at the videos. Yeah, you can omit 9. That's the one we couldn't figure out. Emily looked it up. But yeah, the scanning electron microscope. You can skip that one. I won't count you off. All right. Wonderful. And if you didn't happen to do it, but you don't want the zero, the video's here on Google Classroom for you to watch, and you can just go through and type in the answers that I gave you. Won't be too bad. Bye, Brandon. See you Monday.